Clay lies beneath Chicago sidewalks, inside Yellowstone mud pots, across the Badlands of the American West, and even in material NASA brought back from the asteroid Bennu. Geologists say these clays formed through completely different processes. Mud flood believers see buried cities, a planetary catastrophe, and a civilization erased from history. Haudenosaunee tradition places a handful of earth and red clay near the beginning of both the continent and humanity. The strangest part is that every version points to the same ordinary substance. Most people have held clay without giving it a second thought. It sticks to work boots after rain. It cakes inside the tread of a pickup truck. It turns a backyard into a skating rink and makes a shovel feel twice as heavy. Americans build houses above it, grow crops in it, mine it by the millions of tons, spread special clay across baseball fields, put it in pottery, cosmetics, paper, drilling fluid, medicine, and cat litter. Clay has been part of human life since long before anyone understood what a mineral was. A person could dig it from a riverbank, shape it with wet hands, place it near a fire, and discover that soft mud had become a hard container. That single trick gave people better cooking, safer food storage, bricks, roof tiles, writing tablets, and eventually entire cities. Something so useful ought to have a simple biography. It does not. Clay is not one substance. It is a family name given to extremely fine particles and several groups of layered minerals. Kaolinite is one of them. Smectite is another. Elite is another. Natural clay may also contain quartz, iron compounds, calcium, magnesium, organic material, volcanic glass, and small pieces of almost everything the surrounding landscape has produced. That is why clay comes in so many colors. Iron can turn it red, orange, yellow, or brown. Organic matter can darken it. Some kaolin deposits appear almost white because water removed many of the substances that would normally stain them. Georgia red clay and Georgia white kaolin can exist in the same state without being the same material. One stains shoes and tires. The other enters factories and becomes part of paper, ceramics, paint, rubber, and other products. Georgia leads the United States in kaolin production, which means a substance most people call dirt quietly supports a major industry. The particles themselves are tiny. A grain of sand beside a clay particle looks like a boulder beside a dinner plate. Many clay minerals grow as microscopic sheets. Water slips between those sheets and allows them to slide. That is why wet clay can be shaped. Water does not merely make it dirty. Water changes how millions of mineral plates move against one another. Let the water escape, and the plates draw closer. The clay shrinks and hardens. Heat it strongly enough, and the mineral structure changes again. A fired brick does not turn back into mud during the next thunderstorm, because the original clay has been permanently rearranged. This layered structure also explains why some clays swell. Smectite-rich clay can pull water between its mineral sheets and expand dramatically. Wyoming bentonite is famous for this behavior. It seals ponds, supports drilling wells, binds foundry sand, absorbs liquid in cat litter, and blocks water around buried waste. The same mineral can sit beneath an oil rig and beside a kitchen trash can. Nature has no respect for job titles. Where did all of it come from? The standard geological answer begins with rock. Rain enters cracks in granite, volcanic rock, shale, and other material. The water carries dissolved gases and weak acids. Frost widens fractures. Roots push into small openings. Fungi and bacteria release chemicals that attack minerals. The rock does not simply break into smaller rock. Its internal structure changes. A common mineral such as feldspar contains silicon, aluminum, oxygen, and other elements arranged in a solid crystal. Water removes some parts more easily than others. The original mineral falls apart. New layered minerals grow from what remains. The process resembles taking apart an old wooden barn. Some boards rot. Some are carried away. A few are reused. Years later, a small shed stands in the same place. The wood may have come from the barn, but nobody would call the shed a crushed barn. Clay minerals are new products assembled from altered rock. This process happens everywhere. It works fastest in warm, wet climates, where water moves through rock for long periods. It also happens in cold regions, although frost and ice do more of the initial breaking. Geologists call clay that remains near its birthplace a residual deposit. The parent rock lies below it or nearby. The mineral family and chemistry may still reveal where it came from. Other clay travels. A river can carry the finest particles much farther than gravel or sand. Heavy material drops out when the current weakens. Clay may remain suspended until the water becomes almost still. A lake works like a giant settling tank. So does a quiet bay. The bottom receives a thin mineral film year after year. Each layer looks insignificant. Give the process enough time and the deposit becomes thicker than a house, then thicker than a city block. This is how clay can appear where no mountains stand nearby. The source may have been hundreds of miles away. The river that delivered it may no longer exist. The mountain may have eroded completely. The sea may have disappeared and left its bottom in the middle of dry land. A person drilling through a Kansas field can pass through material laid down when water covered the region. A highway cut in the West can expose stacked colors from environments that vanished tens of millions of years before the first road sign appeared. The landscape does not preserve its old address. Sometimes water moves clay slowly. Sometimes it does the job in one violent night. Anyone who has seen a major flood knows what remains after the water leaves. Floors disappear beneath brown sludge. Cars settle into mud. Basements fill with silt. A clean street becomes a riverbed with mailboxes. Even an ordinary flood can leave several inches of fine sediment. A large mud flow can move boulders, trees, sand, soil, and clay together. A tsunami can carry ocean sediment far inland. A failed natural dam can release more water in a few hours than a normal river moves in months. So the basic claim behind catastrophic clay deposition is not absurd. Water can spread enormous amounts of mud quickly. The argument begins when someone claims that one recent disaster buried entire continents. The mud flood theory has become especially popular in American online communities interested in Tartaria and hidden history. Followers collect photographs of basement windows, buried arches, underground sidewalks, and old buildings with entrances below modern street level. They argue that these were not designed as basements. They were original ground floors. A giant wave of mud supposedly buried cities during the 19th century. Survivors moved upstairs, cleared what they could, and accepted the new ground level. Later, authorities erased the catastrophe from history. The photographs can look persuasive. Chicago has old windows below sidewalks. Seattle has underground storefronts. Sacramento has hollow sidewalks and buried street levels. If a person sees only the final image, a forgotten flood sounds more exciting than a sewer project. The documented histories tell a different story. Chicago began on flat, wet ground where drainage barely worked. The city could not place useful sewers deep below street level because gravity had nowhere to carry the waste. Engineers laid sewers near the existing surface, brought in fill, raised streets, and in some cases, physically lifted buildings. A city block could rise while businesses continued operating nearby. Chicago did not vanish beneath a mysterious overnight deposit. People deliberately moved the city upward because the original ground was muddy, unhealthy, and badly suited to drainage. Sacramento faced repeated flooding. After devastating 19th century floods, parts of the city were raised. Old sidewalks and entrances remained below the new grade. Seattle rebuilt after the Great Fire of 1889. The new street level stood above parts of the old one, creating the underground passages that later became a tourist attraction. These cities contain exactly the kind of photographs used to support mud flood claims. They also contain records explaining how the buried levels were made. That does not mean every underground window in America has the same explanation. Cities grow in layers, streets are resurfaced, buildings sink, hills are cut down, low areas are filled. Railroads change grades, flood defenses raise neighborhoods. A building that began with a half basement may later appear to have a buried first floor. Old construction also returns to clay. Many ancient cities around the world were made from adobe, mud brick, and packed earth. When people stop repairing those walls, rain dismantles them, roofs collapse, rooms fill with material from nearby structures. After enough generations, a neighborhood becomes a hill. A mound that looks natural may contain dozens of cities stacked on top of one another. That fact gives both sides something they want. Archaeologists can explain why old settlements disappear into the ground. Alternative historians can ask how many apparently natural hills have never been properly examined. The useful question is not whether buried cities exist. They do. The question is how they were buried. One fast catastrophe leaves a different pattern from centuries of rebuilding. A violent flood sorts material, pushes objects in one direction, breaks walls, and deposits debris of similar age. A growing city creates mixed layers filled with construction waste, ash, animal bone, household objects, and street surfaces built at different times. A photograph shows depth. It does not show process. The Tartaria version adds a larger claim. According to believers, an advanced civilization once built monumental cities across much of the world. Catastrophe destroyed the population. Later, governments occupied the buildings, hid the old technology, changed the dates, and rewrote history. American government buildings, railway stations, exhibition halls, state capitals, and ornate downtown structures become evidence. Followers ask how people with horses and simple tools could build so much so quickly. The answer that wealthy industrial cities had skilled workers, organized labor, stone quarries, railroads, steam machinery, engineers, architects, and enormous inequality sounds less dramatic. A photograph of construction workers in worn clothes beside a magnificent building creates emotional tension. The workers look too poor to have created the world around them. That feeling is real. It is not proof that somebody else built the city. The conspiracy becomes difficult to test because every missing document can be called evidence of removal. Every surviving document can be called a forgery. Any expert who disagrees becomes part of the cover-up. Once lack of evidence proves the theory no longer needs the earth beneath the building. It can survive on suspicion alone. Clay does not belong only to city conspiracies. It also appears in the oldest flood stories. The Haudenosaunee creation tradition begins with a world above and water below. Sky Woman falls toward the water. Animals help her. A small amount of earth is brought up and placed on the back of a great turtle. The land grows. In one Oneida telling, people are later shaped from red clay. This story does not claim to be a geology textbook. It carries cultural, spiritual, and moral meaning. It still places a handful of earth near the beginning of the world. The image makes sense to people who live near rivers and lakes. Water rises, then retreats. Fresh mud remains. Plants appear. A small patch of wet earth becomes usable land. A person watching a floodplain can see land emerge from mud in a single season. Many cultures tell similar stories. In Mesopotamia, human beings are formed from clay mixed with divine substance. In ancient Egypt, Khnum shapes people on a potter's wheel. Greek tradition gives the task to Prometheus. Biblical and Quranic traditions connect the human body with earth, dust, or clay. Why clay? Stone resists the hand. Water refuses to hold a body. Clay waits between them. It is soft enough to shape and solid enough to remember the shape. Add water, and it moves. Add fire, and it hardens. For early people, that looked very much like dead matter waiting for breath. Science begins from another direction, although the road eventually returns to the same material. Before getting there, we need to visit Yellowstone. A mud pot looks like a pool of clay that has learned to boil. Thick gray or colored mud rises, forms a bubble, and collapses. It appears as if molten dirt is coming directly from deep underground. The real mechanism is stranger. Heat below Yellowstone boils water underground. Steam and gases rise. Hydrogen sulfide reacts near the surface and helps create sulfuric acid. Acidic water attacks surrounding volcanic rock and sediment. Solid rock becomes clay, not crushed rock, chemically altered rock. The mud pot is not merely a hole filled with ordinary dirt. Part of the mud formed because hot acidic water dismantled the minerals around it. Yellowstone makes the geological explanation visible. A visitor can stand on a boardwalk and watch steam, acid, microbes, water, and rock working together. The process is dangerous enough that leaving the trail can cause severe burns. The ground may look firm while hiding boiling mud beneath a thin crust. Lassen Volcanic National Park in California offers a similar lesson. Rain and snow sink underground. Hot rock heats the water. Sulfur-rich fluids rise and attack the landscape. Hard rock becomes weak, pale, colored, or muddy. A mountain can digest itself. The process also helps explain bentonite. Much of the famous bentonite in Wyoming began as volcanic ash. Ancient eruptions spread ash across seas and plains. Water later altered the glassy particles into smectite-rich clay. The volcanic source may have stood far away. Wind carried the ash. Water finished the job. Millions of years later, miners dig up a material that no longer looks like an eruption. Wyoming bentonite can swell many times when wet. That property makes it valuable and troublesome. A layer may crack foundations, damage roads, and deform slopes. The same behavior allows it to seal wells and hold liquid inside a cat litter box. In northwestern New Mexico, Achis Le Pas contains rolling badlands made largely from bentonite-rich material. Erosion cut narrow canyons through the clay and exposed fossils from a vanished world. The landscape looks almost extraterrestrial. Gray hills stand beneath a huge sky. Strange stone shapes rise from the surface. Dinosaur age remains appear in ground that once included volcanic ash and sediment. Here, clay is not a thin stain on a boot. It is the landscape. The American West contains many places where ash, water, burial, and erosion produced colored bands that look as if somebody painted the desert in layers. Each band records a different environment, yet later chemistry may have changed the original material. That is one reason clay becomes such a difficult witness. It can preserve an event and alter the evidence at the same time. The Great Pyramid of Cholula in Mexico demonstrates another problem. From a distance, it looks like a hill with a church on top. Alternative accounts sometimes claim a finished stone pyramid was buried beneath an impossible mass of clay or volcanic ash. The real structure used large amounts of earth and adobe. Once maintenance stopped, rain attacked the outer surfaces. Vegetation spread. Eroded building material merged with natural soil. Volcanic ash may have contributed to the regional deposits. That does not prove one eruption suddenly covered a complete stone pyramid. A city built from earth can hide itself simply by falling apart. The Moai of Rapa Nui created a similar visual mystery. Famous photographs show heads above ground and large bodies below. This invited stories of a sudden flood, volcanic burial, or a civilization swallowed by mud. Many statues remained near the Rano Raraku quarry. Material moved down the slope and accumulated around them. Quarry debris and eroded volcanic soil slowly raised the surface. The statues were buried. That word alone does not tell us whether the burial took one afternoon or many centuries. The same distinction matters in the United States. A house surrounded by 6 feet of fill did not necessarily sink into a flood. A city may have raised the street. A hillside may have moved. A river may have deposited sediment. Construction crews may have changed the grade. Nature and engineering often create the exact image that conspiracy theories need. Then there are places where the earth really does push mud upward. Mud volcanoes occur when gas, water, and fine sediment rise through weak zones. They are especially famous in Azerbaijan, although examples and related features exist in many regions. The material is usually not molten. It may be cool enough to touch, although gas and sudden eruptions can make the site dangerous. Pressure drives a mixture of water, clay, silt, and gas to the surface. A mud volcano does not always manufacture all its clay inside the vent. Much of the material may be old sediment brought up from depth. Water and chemical reactions can alter it during the journey. This creates an uncomfortable possibility. A layer found at the surface may contain material formed in an ancient sea, buried miles below, changed by heat and fluids, then pushed upward long after the sea vanished. The clay seems to have one birthplace. It may have several. This is the point where the entire argument changes. We keep asking which version produced the clay. Weathered mountain, river, glacier, volcano, sea, or deep vent. A single handful may have passed through all of them. Imagine an eruption spreading ash over the west. Rain changes the ash into clay. A river carries the particles to an inland sea. The sea disappears. Burial changes the mineral structure again. Tectonic movement lifts the old seafloor. Wind carries some of the dried material into a new valley. A flood moves it once more. People later build a town above it and use the same clay to make bricks. The clay did not have one birth. It had a biography. This solves one mystery and creates another. If several processes can produce similar material, how do we identify the event behind a specific layer? Geologists examine the mineral mix, grain size, fossils, chemistry, radioactive age, surrounding rocks, and shape of the deposit. A layer that came from volcanic ash may preserve crystals or chemical fingerprints from the eruption. River sediment may show sorting and channels. Deep-sea clay may contain marine fossils. Flood deposits may contain broken material moved in a clear direction. No single test solves every site. The answer comes from many clues working together. Alternative theories often reverse the method. They begin with one large event and assign every unusual layer to it. A shift of the crust becomes a global flood. An asteroid becomes the source of all clay. A destroyed moon explains water, dust, extinctions, buried cities, and ancient myths at once. One cause feels satisfying. Earth history rarely cooperates. Tectonic movement can create clay without a global disaster. When rock masses grind past one another inside a fault, they crush the material between them. Fine fault powder forms. Water enters the broken zone. Reactions speed up because tiny particles expose more surface. An earthquake may last seconds. The chemical factory it opens can operate for thousands of years. A large impact works even faster. Rock shatters, melts, and flies into the atmosphere. Hot water may circulate through the crater for a long time afterward. New clay minerals can form from the damaged material. An asteroid does not need to arrive carrying ready-made clay. It can force Earth to make clay from its own crust. This gives the impact theory a legitimate scientific core. Impacts fracture rock. They create dust. They generate hot water systems. They can produce clay. The leap comes when one crater is asked to explain every thick clay deposit on the planet. Different deposits formed at different times. Their chemistry differs. Their fossils differ. Their relationships with nearby rocks differ. One event cannot easily produce layers separated by hundreds of millions of years. The deep Earth offers another source. Large amounts of water exist below the surface, much of it locked into minerals rather than stored in giant underground oceans. Water moves through fractures, returns through springs, enters volcanoes, and participates in the slow recycling of the crust. Flood traditions sometimes describe waters rising from below as well as falling from above. Modern alternative writers connect that language with deep water and mud volcanoes. The scientific fact does not prove the catastrophic version. Water exists in the mantle and crust. That does not show that it burst through the entire surface during one recent event. The image remains powerful. Perhaps the flood did not come from the sea. Perhaps it came from the planet. A more radical idea comes from the hydride Earth hypothesis, associated with Russian geologist Vladimir Lerin. The model proposes that early Earth contained far more hydrogen than accepted geology allows, and that hydrogen continues escaping from the interior. Supporters sometimes bring selene into the story. Selene contains silicon and hydrogen. It can ignite in air and produce water with silicon dioxide. From there comes a claim that sand and clay may have been created by gases rising from inside Earth. The chemistry provides only part of the bridge. Silicon dioxide is not clay. A clay mineral needs additional elements, including aluminum or magnesium, arranged in layered structures. Water and later reactions would still have to build the final mineral. Deep gases could provide ingredients. They do not deliver finished pottery clay through a crack. Cosmic theories begin with another real fact. Earth receives material from space every day. Dust from asteroids and comets enters the atmosphere. Some grains melt into tiny spheres. Others survive with less change. Tens of tons arrive across the whole planet during an average day. That is enough to leave a constant extraterrestrial trace. It is nowhere near enough to build a clay layer 100 feet thick across a continent. Bennu makes the cosmic argument more interesting. NASA returned pieces of this carbon-rich asteroid to Earth in 2023. Analysis found abundant water-bearing minerals, including clay like phyllosilicates, along with organic compounds and salts formed in an ancient watery environment. This means clay-related minerals are not exclusive to Earth. Water altered rock on the parent body of Bennu long before the sample entered a laboratory in Texas. A piece of cosmic clay can fall to Earth. That fact does not prove that Georgia, Wyoming, or Chicago arrived from space. It proves only that the mineral process can happen beyond our planet and that asteroids can deliver the result. Fringe theories require much more. One says Earth captured a large asteroid or comet. The object came too close, broke apart, and formed temporary rings. Dust then fell for centuries or millennia. The broad physical idea is possible. Gravity can tear apart weak bodies. Planets can have rings. Debris can fall. A ring massive enough to cover continents with deep deposits should leave a clear global chemical layer and a common date. No such layer explains all clay. An Eastern European esoteric tradition gives the destroyed bodies names. Lelia and Fata are described as former moons of Earth. Their destruction supposedly released water, rocks, and dust. The impacts caused floods. Fine material remained in orbit and later fell as clay. The story is often presented as ancient Slavic knowledge. Reliable early sources do not support that claim. It belongs to a modern esoteric system. Its appeal is obvious. A shattered icy moon provides water, impacts, darkness, dust, and a reset of civilization in one package. Another theory moves the source farther away. The solar system may have traveled through a dense interstellar dust cloud. Earth collected the material as it moved. Interstellar dust exists. The solar system moves through the galaxy. Denser regions exist. The missing piece is the clay layer. Nobody has found a galactic band of ready-made soil waiting for planets to cross it. The most extreme cosmic version makes the Sun responsible. The Sun supposedly changed its structure, lost part of an outer shell, or released a massive wave of material. That wave destroyed smaller bodies and covered Earth with dust. Supporters sometimes point to old fork-shaped crosses or solar symbols and interpret them as memories of the event. A symbol can preserve memory. It can also resemble whatever a modern viewer hopes to see. Without matching physical evidence, the symbol cannot carry the whole theory. A related claim says a coronal mass ejection struck an asteroid or comet, ground it into atomic dust, and swept the material toward Earth. Silicon then burned in the atmosphere, creating sand and clay while consuming enough oxygen to kill giant animals. Coronal mass ejections are huge in total mass and extremely fast. They are also spread across enormous volumes of space. They are plasma, not a solid wall of sandpaper. Even if silicon oxidized, the product would not automatically become layered clay. The oxygen claim also fails by scale. A passing cloud cannot easily consume enough atmospheric oxygen to explain major biological changes. The theory begins with real solar physics, and then asks that physics to perform work far beyond its known ability. Plasma catastrophe theories make an even larger claim. Earth supposedly experienced giant electrical discharges from the Sun, another planet, or a passing object. The discharges carved landscapes, melted rock, burned cities, and threw mineral dust into the sky. Rain turned the dust into mud. Lightning can melt sand. Electrical arcs can damage stone. Plasma exists throughout space. A laboratory spark does not prove that a cosmic bolt resurfaced North America during historical time. Ancient war theories follow the same pattern. They point to melted stone, glassy desert surfaces, buried cities, and stories of weapons from the sky. An advanced civilization or extraterrestrial group supposedly used weapons powerful enough to alter the planet. Volcanoes melt rock. Meteor impacts make glass. Lightning creates fused sand. Great fires damage masonry. Ancient writers describe terror with the strongest images available to them. Each clue needs its own investigation before all of them become one forgotten war. Another American branch of alternative history sees Earth as an ancient mine. Canyons become excavation scars. Flat-topped mountains become stripped work sites. Desert clay becomes waste left after valuable minerals were removed. Modern mining makes the comparison tempting. Mines create giant pits. Processing plants leave fine tailings that look like mud. Entire hills can be built from waste. A planetary mine should leave organized patterns of chemical removal, machinery, transport routes, and deposits with consistent industrial signatures. A canyon alone is not a receipt from an alien mining company. Then comes the giant tree theory. Devil's Tower in Wyoming looks like an enormous stump. Vertical columns resemble wood grain. The top appears cut flat. Online communities claim it is the fossilized remains of a silicon-based tree from a previous world. The National Park Service explains Devil's Tower as magma that cooled below the surface and was later exposed by erosion. Geologists still debate details of how the magma body formed and cooled. They do not debate whether it was a biological tree. The tower also holds deep spiritual importance for several Northern Plains tribes. Traditional stories involve bears, people, and the sacred landscape. Those traditions should not be confused with the modern internet theory about a silicon stump. A shape can inspire a story without proving the story physically. A cloud resembles a ship. A mountain resembles a face. A rock column resembles bark. Human vision is excellent at finding familiar patterns. It is not a laboratory instrument. The Matrix version removes even the need for a physical catastrophe. In that theory, reality operates like a programmed environment. Civilizations are periodically reset. The old surface is covered with sand and clay because these materials hide detail, fill rooms, and create a clean layer for the next version. Buried windows become errors in the update. Unexplained buildings become objects copied from an earlier map. The theory cannot be tested easily because any evidence can be declared part of the simulation. A contradiction becomes a glitch. Missing evidence becomes successful deletion. That makes the Matrix useful for philosophy and fiction. It makes poor geology. The final group of explanations does not treat clay as the end of a destroyed world. It treats clay as a beginning. Microorganisms help create and alter clay. Bacteria and fungi release compounds that attack minerals. They change iron chemistry. They influence which substances dissolve and which ones form again. Clay is not made from decayed dinosaurs or ancient manure. Even if that version makes a memorable comment under a video, life still participates in the process. Some clay minerals form directly within marine sediment. Dissolved elements react with silica, water, and material produced by microscopic organisms. New minerals grow on the seafloor instead of arriving from a distant mountain. Later, tectonic movement can raise the old seabed. A clay deposit in a dry American landscape may have formed beneath water. The United States contains entire regions that once lay under inland seas. Fossils now appear in ranchland, deserts, road cuts, and clay pits. The ocean did not lose its way. The continent moved and the water level changed. Clay continues changing after burial. Pressure rises, temperature rises. Water moves through pores. One clay mineral can transform into another. This creates the central difficulty. The deposit may no longer look like the material that first settled. The original source has been edited. Clay preserves history with the reliability of a family story told for the 20th time. The main event survives. Names change. Details move. Somebody adds a flood. That brings us back to life. Early Earth had water, volcanic activity, minerals, gases, and intense ultraviolet radiation. It did not have a modern ozone shield protecting the surface. Organic molecules floating freely in water faced destruction. They also faced another problem. They had to meet one another in useful arrangements. Clay offers surfaces. Molecules can attach to those surfaces. Instead of drifting far apart, they gather in one place. Some clay minerals can orient molecules in ways that make reactions easier. Experiments have shown that clay can help certain small molecular units form longer chains. Kaolinite and montmorillonite can also provide partial protection. Nucleic acids attached to clay have shown less damage from ultraviolet radiation than the same material left exposed. On young Earth, a clay particle may have worked like the first piece of shade on a beach with no shelter. That does not mean clay suddenly became alive. A protected molecule is not a cell. A long chemical chain is not a thinking organism. The gap remains enormous. Clay may have helped with a few early steps. Nobody knows whether those were the decisive steps. NASA now includes mineral surfaces, including many clays, among the environments worth considering when scientists ask how non-living chemistry became organized enough to move toward life. This gives the ancient creation stories a strange echo. Haudenosaunee tradition places Earth at the beginning of land and red clay near the making of people. Mesopotamian stories shape humanity from clay. Biblical tradition forms a human from earth and adds breath. Science does not confirm that a hand shaped the first person from wet soil. It does allow a quieter possibility. Without mineral surfaces, including clay, some of the chemistry that led toward life may have been far less likely. Myth says the body came from clay. Chemistry asks whether clay helped the first biological ingredients meet. The statements are not the same. They stand uncomfortably close to one another. This closeness gives extraterrestrial theories one final opportunity. If clay can hold water, concentrate chemicals, protect molecules, and help reactions, perhaps an advanced civilization would spread it deliberately while preparing a planet for life. In this version, clay is not waste from a catastrophe. It is part of a terraforming system. First, crush the rock. Then, add layered minerals. Let them hold water and chemicals. Build soil. Start biology. There is no evidence that anyone did this to Earth. The idea grows from genuine properties of clay and then invents an engineer behind them. That is how many alternative theories begin. Nature produces a mechanism so useful that somebody assumes it must have been designed. Clay does perform one task that feels almost designed. It remembers. Fired clay tablets preserved laws, myths, taxes, inventories, and personal debts for thousands of years. Paper vanished, wood rotted. A burned tablet survived long enough to tell modern scholars who owed grain to whom. Natural clay layers also preserve pollen, ash, fossils, chemical traces, ancient water conditions, and changes in climate. Clay is an archive. It is an archive with terrible handwriting. Water alters it, roots disturb it, animals mix it, pressure changes the minerals, later floods add new material. Human construction adds brick, ash, glass, bone, and garbage. The archive survives, but the pages stick together. That is why the same layer can become evidence for slow geology, a single flood, a buried civilization, or a cosmic reset. The clay itself does not choose. It waits for somebody to study the age, mineral structure, surrounding rocks, fossils, direction of movement, and chemical fingerprints. Science knows how clay can form. It does not always know the full biography of every deposit. That difference matters. Saying that clay is unexplained is wrong. Saying that every clay layer has a simple explanation is also wrong. A deposit beneath Chicago may include natural lake sediment, local clay soil, river dredging, construction fill, old brick, street waste, and material deliberately added during grade raising. A Wyoming bentonite bed may begin with ash from a volcano that vanished long ago. A New Mexico badland may preserve fossils inside clay created from several stages of deposition and alteration. A particle from Bennu may have formed around water on another world before NASA carried it into a clean laboratory. A handful from an American backyard may contain rock from a vanished mountain, sediment from an ancient river, dust moved by wind, minerals changed by groundwater, and a few grains that entered the atmosphere from space. One handful, several pasts. This is the real reason clay works so well in conspiracy theories and myths. It covers things, it preserves things, it changes shape, it arrives through water, it comes from broken rock. It can form underground and fall from the sky as ash. Clay looks like the perfect residue of a destroyed world. It also looks like the perfect material for building the next one. Perhaps clay is not the mark of one catastrophe. Perhaps it is the substance Earth uses to process the marks of almost every catastrophe. A volcano throws ash into the air. Water turns part of it into clay. A glacier crushes rock. Rivers carry the powder south. Wind places it on the bluffs above the Mississippi. An asteroid breaks the crust. Hot water changes the damaged minerals. A city raises its streets. Old entrances become underground rooms. An adobe wall collapses. Rain returns the building to mud. A sea disappears. Its bottom becomes a field. A civilization dies. Its clay tablets keep speaking. Clay preserves the event and erases the signature. Then the planet places a piece of that recycled past beneath a sidewalk, inside a canyon, under a farm, or on the sole of a boot. And it asks us to guess what it used to be.